Hey, geometry students, I am going to go through lesson 6.2, which is on page 171 of your student journals. All right, so in lesson 6.2, there are some vocab words that we need to kind of walk through. The first one is called concurrent. And basically what it means is, and we'll write it down, two or more lines raise segments that intersect at the same point. Oops. All right, that point, this point that we're referring to here is called our point of concurrency. And so then there's going to be some specific, I guess, intersection points that we need to be aware of. And the first one is called a circumcenter. And that's the point where the three perpendicular bisectors, so that's the key word here, perpendicular bisectors of a triangle intersect. So we call that the circumcenter. It's the point at which three perpendicular bisectors of a triangle intersect. The point where the three angle bisectors so there's angle bisectors intersect is called the incenter. And so there are a couple different vocab terms that we're going to talk about. All right, so I'm going to show you how to do the construction of that here in a bit. But first, let's talk about the theorems for each one. So the Circumcenter theorem basically says the circumcenter of a triangle is equal distance from the vertices of a triangle. So if this point, so here's the, if you look at D to P, E to P, and F to P are the perpendicular bisectors of all three of those side lengths. And so they all meet at this one point called P. And so what's special about a circumcenter is that the distance from P to the vertex on any of the vertices is always going to be equal. So we can mark them all as congruent. So all of those lengths are equal. All right, let's turn your page to page 172. And let's look at the Incenter theorem. So the Incenter theorem is kind of the same deal. Again, remember we're talking about angle bisectors. So if you notice, BP, CP, and A to P are all angle bisectors of each of the three angles of our triangle. And so P right here, this one, is called our incenter. And so what we're basically getting at here is that if A to P, B to P, and C to P are angle bisectors, then the lengths P to D are equal to P to E and P to F. So this makes all of these lengths right here congruent. All right, let's do a problem. So on this one, let's just do number 1. I'm going to go ahead and label our diagram with what we have given to us. So N to D is 2x minus 5. N to E is 2x plus 7. And it asks us to find N to F. So what we're getting at here is you have to recognize what kind of point we're dealing with. So if you notice, these are all perpendicular bisectors. So these are all the perpendicular bisectors or all these lengths are perpendicular, I'm sorry, not necessarily they're perpendicular to your side of your triangle. And so what we know is kind of based off of what we talked about in our incenter. We know that this is called an incenter. So that's like where all three angle bisectors meet. And so when all of these are perpendicular, we know that they're equal. So all we have to do here is set those equal to each other. All right, let's do the math. All right, we get x to equal 3, but remember our goal is to find NF. So N to F is a length of, so we have to plug in 3 to one of our equations here. And I get 6 minus 5, which is 1. So that's basically kind of a straightforward way of kind of looking at those perpendicular, or like the incenter or the circumcenter, just recognizing those relationships. All right, on Canvas, I have posted this lovely sheet that's called, I called it Relationships Within Triangles. So it looks like this, and it has like 4 different vocab terms on it. And so what we're going to fill in today is 2 of them. All right, so we're going to talk about a perpendicular bisector. So let's draw a triangle in here. And what we're basically doing is when we do a perpendicular bisector, we have to make sure this is the midpoint. So that means this piece and that other piece are equal. And that it has to be a bisector, which means, or it has to be perpendicular, which means that it has to come straight up and it has to meet at a right angle. So that would be the perpendicular bisector. It doesn't have to go through a vertex or anything like that. So if we did all 3 perpendicular bisectors, so we did the perpendicular bisector for just this one side, and if we did all 3 perpendicular bisectors, we would call that point the circumcenter. So I'm just going to write down the definition here so I kind of remember. And then in this stage, I'm just going to write down kind of what the circumcenter tells us. So I'm going to say the circumcenter P of a triangle is equidistant from the vertices of the triangle. All right, let's draw a picture of this so we can kind of get a better feel. So draw another triangle. It doesn't have to be anyone in particular. I'm trying not to draw an equilateral triangle, but I guess it technically doesn't matter. All right, so what I'm getting at here is if we do the perpendicular bisectors, so if I took the midpoints of all of these sides, and then if I literally, and I'll show you how to construct this in a minute, but I'm going to kind of do this with my compass or my straight edge here. And if I just made perpendicular, oops. A little off. But anyway, this point here in the middle, just kind of bigger, this point in the middle is called our circumcenter. And so what we need to remember is that that is equal distance from each of the vertices. So if you want, you can kind of draw in your length to your vertices. And what we know is that all 3 of these lengths are equal. And so we can mark them as congruent. All right, angle bisectors. Let's do another one. So I'm going to draw another triangle over here. And an angle bisector basically just bisects an angle, right? So all we do is, and I'll show you the construction here in a minute, but basically what we're doing is we're cutting this angle in half so that those 2 pieces are equal. So an incenter all right, so in this one, an incenter, remember, is all three angle bisectors of a triangle. And so the terminology I want us to put in this box, I'm just going to say the incenter, we'll call it I, of a triangle and remember, an incenter is equidistant from the sides of the triangle. So circumcenter is equal distance from the vertex, and an incenter is equal distance from the sides. Let's draw another triangle. And so if we get our angle bisectors, I'm just going to kind of real quickly draw in what I would think would be an angle bisectors for each one of these. So they're all going to meet at a point, and that point, remember, is called the incenter. So this is our incenter. We'll call it I. And then what's special about this particular incenter, or that all incenters for a fact, is that it's equal distance from each of the sides of the triangle. So that means this piece, and this piece are all equal. All right, so I made this sheet just so we can kind of keep our terminology straight. And so we're going to add to it the other two definitions at a later time. All right, if you haven't already, you're going to want to grab a piece of paper because we're going to do some constructions. You're also going to need your compass. All right, so we're going to do, I'm going to call this 6.2 constructions. And I am going to construct first. I'm going to construct a circumcenter. All right, so start by drawing a triangle. It doesn't really matter what triangle you draw. I'm just going to draw anyone like that. So start by drawing a triangle. All right, so remember, a circumcenter, remember from our sheet, are the perpendicular bisectors of all three sides. So what you want to do is you want to construct the perpendicular bisectors of each of your sides. So what you're going to do is, we'll call this, I guess, A and B and C. So if you remember the construction for a perpendicular bisector, let's do A to B. What you do is you put your compass on point A and you pick a point that's on your compass that's more than halfway. So I'm going to pick this point S and I'm going to draw an arc. And I'm going to swing my compass to the other side. I'm going to pick the same measurement and I'm going to draw an arc the other way. And what you'll notice is that you'll get both of those arcs kind of make like two X's. And you're just going to draw the line that goes in between them. All right, so that's one perpendicular bisector. Let's do another perpendicular bisector. So let's do the perpendicular bisector of C to B. Put your compass at C. Pick a distance that's more than half and make an arc. Put your compass at B, pick that same distance, and then they should intersect. Now these constructions get a little confusing because we got like multiple marks on one diagram, but just do the best you can. I like to use different colors so that way I can see. Now you can do the third perpendicular bisector, but it's not required. So if you notice, my two perpendicular bisectors intersected here, and we're going to call that C for a circumcenter. And that's the construction for a circumcenter. All right, let's do a construction of an incenter. All right, so again, I want you to start by drawing a triangle. You need to use a straight edge, please, just so that everything lines up correctly. All right, so again, you don't have to draw a specific kind. Mine looks like this, so that's fine. Remember, an incenter are angle bisectors. So we're going to bisect any two of these angles. So I'm going to call this A, B, and C. I'm going to bisect angle A and maybe angle B. All right, to bisect angle A, put your compass at point A and pick a distance that's not too far away. So I'm going to pick like something kind of close and make an arc so that it intersects both parts of the triangle. So using that same distance, do you see where kind of these two lines now intersect? I want you to put your and that's an angle bisector. All right, let's do an angle bisector for B. So it's the same steps. So we're going to put your compass at B. You're going to pick an arc, pick a measurement for your arc. You're going to slide your compass to the two intersection points. Using that same measurement, you're going to make an arc on the inside of your triangle. I'm going to swing my compass to the other side and finish off this arc. All right, pay attention, because like here's where mine, so again, a lot of things are kind of, lots of lines here, but connect where the X marks the spot with your angle bisect, or with your angle, with your vertex, and you should be able to see where the two angle bisectors intersect. And so my two angle bisectors intersect right here, and we're going to call that an incenter. All right, we're going to now do, for the third construction, I'll give you a second to write this one down, but you're going to do circumscribing a circle about a triangle. So that's a fancy way of just saying, basically you're going to draw a circle around your triangle. So I'm going to label this A, B, and C. And then I am going to construct the first step. I'm going to construct the perpendicular bisector of AB. So we just did that construction. So that one hopefully is a little bit fresh in your memory. If you remember, you're just going to put your compass at point A, pick a distance that's more than half. Go to the other side. And then you're going to go ahead and construct it. All right, draw in your perpendicular bisector. That looks like that. All right, so what we're going to now do is we are going to draw the perpendicular bisector of B to C. So we're going to basically construct the circumcenter here again. So let's do a perpendicular bisector of B to C. So I'm going to go ahead and grab a different color here, put my compass at C, pick a distance that's more than half, swing it around, use that same distance, and then I'm going to connect the dots. All right, so once you've gotten your two perpendicular bisectors, we should be able to find our circumcenter. So let's make a big there and call it our circumcenter. Now, we're going to label that, I'm just going to call, well, I guess I can't call it C, right, because we already used C. So let's change this to a D, just because that's the next letter in the line. All right, place your compass at C, and what you're going to do is you're going to measure the distance from D to any of the vertexes of the triangle. This is going to be the radius of the circle that you're creating. So it doesn't really matter because remember, a circumcenter is the same distance from all vertices. So what you need to do is find the one that matches. And then what you're going to do, you're going to draw a circle. So if like mine kind of matches here, I'm going to draw a circle all the way around. Okay. If I can draw this. And that's your triangle that's inside of a circle. Now mine, you can see it's not perfect. See, it didn't really 100% go through that vertex, and that's okay. It happens, so no worries there. All right, last but not least, for constructions at least, we are going to construct inscribing a circle within a triangle. So on this one, what you're going to start with, you're going to draw the angle bisectors. So you're going to find the incenter of your triangle. So let's do an angle bisector. We'll just pick, I'll call this A, B, and C. So we'll go A, B, and C. So I'll do the angle bisector of A, and I'll do an angle bisector of C. So if you remember how to do it, great. And I'm going to finish this off. And I'm going to draw in my angle bisector. All right, and then I'm going to go ahead and draw an angle bisector of C. Again, it gets a little tricky with all these lines in here, so just be careful that you're matching up the right ones. And so where those two angle bisectors intersect is going to be called our incenter, right? So we'll label it D like we did the other one. All right, once you got your angle bisectors and you got your incenter in there, you're going to draw a perpendicular line from D to AB. So to do that, you're just going to use your straight edge and draw the perpendicular line. I'm going to go ahead and switch colors from point D to AB. So in order to do that, you have to construct a perpendicular line from a point to a line. So what you do is you put your compass on your point. So let's put our compass on D. I'll show you how to do this construction. And so you want to pick a distance. I'm going to use like K here. I just want my arc to intersect segment AB in 2 spots. That's all I want. So do you see how it intersects it in 2 spots? So I used K as my distance if you have the same kind of ruler as me. All right, I'm going to go to this intersection point over here. If you notice, there's 2 intersection points. Put your compass on one of the intersection points, and you can use the same exact measurement that you did and make an arc, and slide it over to the other one and do the exact same thing. And then if you line these up, the point D and that X, this should now be perpendicular. All right, last but not least, you're going to place your compass at D, and you're going to measure the distance to E. So E is this new point now we found here. So that's that perpendicular, where that perpendicular line intersected. So we're going to measure the length of DE. So put your compass at D, measure your length of D to E. So mine's about right here. And now I'm just going to go all the way around. And now you will see that I have a circle inside of a triangle. All right, so those ones, I have a whole section of constructions on Canvas. I would encourage you to try those again. I know it's hard to kind of follow along, but feel free to pause the video and so forth. All right. Next, what we're going to be talking about, grab this. All right, so next what we're going to be talking about is how to actually find the coordinates. So there was a couple different things that I want you to be able to do with this. What we're going to do is I want you to write down this question. It says, find the coordinates of the circumcenter of triangle DEF with vertices, and I gave you D is the point 64, E is the point -24, and F is the point -22. All right, it's helpful if you grab a piece of graph paper because doing this without graph paper, if you are off by a little bit, then this will cause some issues. All right, so start by graphing all 3 points on your grid. And so what I did is I just graphed -2, 4, 6, 4, and -2, -2. All right, so we graphed all of our points. That's step 1. Step number 2, I want you to find the midpoint of E to D. So this one's fairly easy. Because it's a horizontal line, the midpoint is just literally halfway in between, and most of you could probably just tell, but it happens to be at the coordinates 2, 4. So that's what I'm going to write down. Next, you're going to find the midpoint of E to F. So we're going to do the same thing with this vertical line. Again, it's easy to find the midpoint because it's vertical. And I got -2, 1. So now what I'm going to do is I'm going to connect. So I'm going to draw in those perpendicular bisectors. So I'm going to connect this, a line that's perpendicular. So that would be a vertical line. And I'm going to connect through this midpoint here. I'm going to connect this horizontal line. Where those two intersect, so this point right here is called our circumcenter. And that would be how you label, and you would label it as 2, 1. That's it. That's all you're going to do. So part of your in-class work is to do some of this, and so you may need some graph paper. So I would encourage you, as you do some of your work, especially in big ideas and so forth, that you grab some graph paper. All right, that's all for now. Thanks, guys.